So at some point this thing stopped. Oops. Let's just break it. At some point this thing stopped. Sorry about that. Alright. So, let's take a video of that. So at some point, when we were talking about base and having the 0 be the slope at the bottom, right? At the bottom of this curve, you're looking for when the derivative is equal to the value of the slope is equal to 0 is also the axis of symmetry, right? So we set it equal to 2ax plus b, or the derivative is 2x plus 2 equals 0, because at that point the slope is 0. Then we solved, so the axis of symmetry was -1. Then we took that axis of symmetry, plugged it in, substituted it into the original equation, found what the point was at the minimum value for that equation. That was -1, -4. After, sorry about that, doing some simplification, right? And AS. And then we wanted to find the y-intercept by plugging in 0 for x. We knew that the y-intercept would be -3. So by definition of the y-intercept, we knew that it would cross this line at 0, -3. So that's one point of intersection. And then we started to look at the other axis of intercepts, the x-intercepts, which is -b plus or minus the square root of b squared minus 4ac all over 2a, right? The quadratic formula. Once we plugged in b, a, and c, we then solved using simplification, right, of the exponents, right? Multiplication, division from left to right, and addition, subtraction from left to right. And as we simplified it down and down and down, right, simplified the top, we also found the square root of 16 to be 4. Then we did two separate solutions. One solution is at 1. That means it's coming up here at 1. Right? But the other solution was at -3. That should be negative, because it was -6 divided by 2, -3. And so after simplifying, we found that there were two points of intersection, and that is -3 and 0, and 0, -3 is where the curve intersects with the line. So that is problem number 4 in a nutshell. Any questions? Pretty easy? Yeah. Right?